I really want to go over this because it's been a while. So fundamental theorem of calculus questions, I know I did problem 1 yesterday, but these are really simple if you remember what it says. It says that a derivative and an integral cancel each other. So all we have to do is replace that t with the x squared. So we have x squared squared plus 1 squared. And then since it wasn't just a plain x, we have to do times the derivative of that. So you should get 2x times x to the 4th plus 1 squared. And that's it. Number 2, it didn't say fundamental theorem of calculus, but it said do the derivative of this integral. So if you were really ambitious, you could integrate that and then do the derivative, but that would take a lot of extra time. One thing is a little weird about this. It went from a variable up to the constant. The fundamental theorem would have to go from the constant up to the variable. So in order to flip that, what do we have to do? A negative. So then to do this derivative, we replace the t with the 4x. And since it wasn't just a plain x, we have to multiply by the derivative, which is 4. So we get negative 4 cosine. You could leave it as 4x cubed, or 4 cubed is 64, x to the 3rd. Are we good with those? So there'll probably be a couple questions like that on your test. As long as you pay attention, it should be easy points. Plug them in, multiply by the derivative. If you have to flip it, you throw a negative in front. All right, number 3. We want the total area enclosed between that curve and the x-axis. So first, we need to figure out where this hits the x-axis. So we set that equal to 0. We could take out an x. This would factor into x minus 5, x plus 3. So it hits the x-axis at 0, 5, and negative 3. Okay, let's try to get a rough picture from here. Really all I need to know is it above or below the axis? So if you put in negative 1, you could put it in the original, and we could put it in right here, we get negative 1 times negative 6 times 2. So negative 1 gives us a positive answer. I don't even really care what it is. I just need to know that this is above the axis. If you put in a positive 1, you get 1 times negative 4 times 4. So that's a negative. Again, you could have made your graphs more accurate. I just really need to know, is it above or below? So your graph looks something like this. I'm trying to find these areas. But you have to be careful. You can't just integrate from negative 3 to 5, because what that will do is count this as a positive and that as a negative and subtract them. Because I said the total area enclosed. That's like asking for the absolute value. So we have to do pieces. So we're going to go from negative 3 to 0, and then we're going to go from 0 to 5. Between negative 3 and 0, the graph was above the axis, so we're just integrating our function. Since this is below, what would you need to do? Is everybody with me so far? Making corrections as needed? So the antiderivative of x cubed, I'm going to go down here, I need more space. It would be 1/4 x to the 4th. This would be 2/3 x cubed, 15/2 x squared. Okay, this one, I'm going to go ahead and distribute my negative, so negative 1/4 x to the 4th plus 2/3 x cubed plus 15/2 x squared. All right, and so then if we plug in, we get 0 minus 1/4 plus, a negative cubed is negative, so that becomes plus 3 to the 3rd, you could cancel a 3, so 3 squared is 9, times 2 is 18, minus 3 squared is 9, times 15. If I'm being very honest, I don't really try to make your study guide numbers work out pretty, so you may have had to pick up a calculator on this one. Just know that I will put more effort into making test questions come out nice than I do on these. And so then you should get 863 over 6, I believe, when you plug all that in. Is that okay with everybody? Understand the setup. Ignore my negative or my ugly numbers on that one. So the next chunk, this is the integration by substitution. This is what we have struggled with a little more. So please, 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 I cannot stress enough that you need to be using good notation here. That's what we had an issue with when we took the quiz, not writing things out and then not knowing what you had. So when I look at this, we try to make our u be the inside. What's the inside here? 4x to the 4. Okay, so currently what I have, this would be a sine of u. But we have to get rid of all of the x's. So we also have to get rid of this x cubed and the dx. So what we do is we do the derivative of u. Now, du, the derivative of u, that does not come from the problem. This comes from right here. So the derivative of that is 16x cubed dx. We need the x cubed and the dx. We don't need the 16, so we divide that over. So I replace this x cubed and dx with 1 over 16 du. Okay, you can write that in front. You can pull the 1 over 16 in front of the integral. It doesn't matter at all. So the antiderivative of sine is negative cosine. So we get a negative 1 over 16 cosine of u. Because we don't have limits, we put the plus c. And then at the very end, we need it to be in terms of what we started with. So it's 1 over 16 cosine. What is u? If it helps you in these problems, grab a highlighter. Highlight, you know, what's my u? What x's do I still have? And make sure you've got everything covered. Is that one okay? So number 5. We'll go from 0 to pi over 2, sine squared x cosine x dx. All right, so if I'm going to pick my u, we have sine and cosine. Pick the one with the higher power. So I'm going to make my u just be sine. I don't want to make it sine squared because then when you do that derivative, you have to do the chain rule and it's going to get ugly. I just want the regular sine. So then du, what is the derivative of sine? Sine x dx. So we've got the sine taken care of, and we have the cosine x dx taken care of. We don't have anything extra. And when we set this up, I think most of you changed your limits. A couple of you don't, and as long as you plug back in your sine x before you evaluate, that's fine. So if I do go ahead and change them, you're plugging them in right here. So if x is 0, sine of 0 is 0. If x is pi over 2, the sine of pi over 2 is 1. So then we have u squared du. Antiderivative of u squared is 1/3 u cubed. Since I changed my limits, we can just plug them in here. So 1/3 times 1 cubed minus 0 cubed is 1/3. If you kept it as 0 and pi over 2, then you need to replace your u with sine x before you plug in. So a couple ways of doing it. Problem 6. So u should be the inside. Again, we have to use the u here because we have x's being multiplied together. Is there any such thing as a product rule in reverse? No. So we have to do substitution. What's my inside? So du, the derivative of that, 3x squared dx. So if I look at my problem, I'm replacing that x squared dx is here. We don't need the 3, so I'm going to divide that over. So we have the interval. If we plug in a 0, 0 cubed plus 1 is 1. If we plug in a 2, 2 cubed is 8, plus 1 is 9. We have 1/3 square root of u, or you could write that as u to the 1/2 d. Is everybody with me here? You really want to make sure you understand the substitution before tomorrow, because there will be several problems involving that. So if we add 1 to the power, that's 3/2, so we need a 2/3 in front times my 1/3, so 2/9. So a 3/2 power, that's like saying the square root cubed. Square root of 9 is 3, to the 3rd is 27, square root of 1 is 1, cubed is 1, so we get 26 times 2/9, so 52 over 9. Number 7. This is the problem that I had the typo on that I asked you guys to fix yesterday. So I want the denominator to be x to the 4th minus 5 squared dx. So what is my u going to be? X to the 4th minus 5. Don't make it too much. Don't do the x to the 4th minus 5 squared, just the inside part. Then my du, the derivative of that. So the derivative of x to the 4th would be 4x cubed, derivative of 5 is 0, and we get the dx. Do I want the 4? So what did you guys do? Divided over the 4, so 1/4 du is x cubed dx. Alright, so if I plug in a 1, 1 to the 4th is 1, minus 5 is negative 4. Put in a 2, 2 to the 4th is 32, minus 5 is 27. No, I did 2 to the 5th, didn't I? 2 to the 4th is 16, minus 5 is 9. Sorry about that. Okay, so we have the 1/4. And we have the du times. We are replacing the x cubed dx with the 1/4 du. So that 2 is going to stay. I'm replacing x to the 4th minus 5 with a u. So 1/4 times 2, that's 1/2, over u squared, so u to the negative 2, du. Antiderivative of u to the negative 2, if you add 1 to the power, that's negative 1. So we need a negative in front. So we have 9 to the negative 1 minus negative 4 to the negative 1. What does a negative 1 power do? Flips it. So this is 1/9 plus 1/4. So that's like 4 over 36 plus 9 over 36. So 13 over 36 times negative 1/2, so negative 13 over 72. Any questions on this? So, moving on, I have a few more of the substitution problems. When you look at problem number 8, do I need substitution on this one? No. It's a 2 square root of x, that's like 2x to the 1/2 over x dx. Simplify first. We've done these. And we said, okay, if you have an x on the bottom, it's like dividing each of those by x. So subtracting their powers. So that's x squared minus 2x to the negative 1/2 dx. And then we don't even need substitution. So the antiderivative of x squared is 1/3 x cubed minus 2. Okay, x is negative 1/2. If you add 1, that's a 1/2. So you need a 2 in front. We don't have limits, so plus c. So we get negative 1/3 x cubed minus 4x to the 1/2 plus c. So I might put a problem on the test where you don't have to do substitution. Just see if you recognize that. Problem number 9, do we have to do substitution here? You wouldn't have to. You could multiply all this out, couldn't we? Did you guys do substitution? It's not wrong. Let's try it if you did. So your inside would be b squared plus 2. So du would be 2b dv. We don't need the 2, so 1/2 du equals b dv. So we have u squared times the 1/2 du. Antiderivative of u squared would be 1/3 u cubed. We need a plus c on this one. And then replace your u. U was b squared plus 2. If you did it by multiplying everything out, you would have had 1/6 b to the 6 plus 2/3. No, that's wrong. 1/6 b to the 6 plus 1/2 b to the 4th plus 2b squared plus c. If you did it by multiplying everything out first. So equivalent answers. Are we okay with that one? Yeah.
Could you do a problem where it's not, it doesn't fit, like, you know, like the DV,
Where
like the V fits in, you know, like in the front.
so where there's because we can't do it 2/3 power, so we would have to do substitution. So your inside would be x minus 3. The du, derivative of x minus 3 is just 1 dx. Is that what you're meaning with? So right now, this gets replaced with my u. This gets replaced with du. But we have an issue because we still have another x out here. So we have to take this and solve for x. So u plus 3 equals x. So we change that x to a u plus 3. Then we have u to the 2/3 du. And this doesn't look like it helped us much, but it actually does, because now you could distribute. So if you add those exponents, and then we could integrate. So add 1 to your power, you get 3/8. So u to the 5/3, so 3/5 times 3, so 9/5 plus c, and then replace u was x minus 3. So if it doesn't fit exactly, you have to figure out what to plug in for every one of your variables. Is that okay?
Thank you.
You're welcome. Okay. Question number 10. I told you that R of t was the rate. it's like representing a derivative. So I want to know what this would represent. So RT is the rate, gallons per minute. We know that a derivative is a rate. So if we go backwards from a derivative, what would it be? So like think back to the things we've done. You know, cost. The derivative is marginal cost. It's how you're changing. So if you have how the cost is changing, when you go backwards, you get your true cost. If we think about position, the derivative is velocity, so it's your rate of change. But when you go backwards from that rate, you're back to your position. So we're down here, our rate is in gallons per minute, so when I go backwards, it's just giving me the amount, the gallons. Okay, so going backwards, this would be the amount of oil in gallons. The 0 and the 120 were my times, so that leaves between 0 and 120 minutes, or over a 120-minute period. So if you have a rate, going backwards gives you an amount. So if I had the rate of sales, think about a business application. If I gave you the rate of sales, it's telling you how sales are changing. So if I go backwards, what would it tell me? The amount. So if I were talking about the sales, the rate of sales of Lotus drinks, going backwards would tell me the number of Lotus drinks that were sold. Okay, if I were talking about the rate of sales of shoes, going backwards tells me the number of shoes that were sold. Okay, so a derivative is a rate. When you do the antiderivative, you're back to your amount. Is that one okay? Number 11. So I've given you, now we're into the most recent stuff that we've been doing, the chapter 6 stuff. So we have the region enclosed by two curves. I would ask you to draw a sketch, but it doesn't have to be anything too fancy. If I want to know the region between them, you need to find out when they meet. So if I add over my x squared, add over my 12, divide by 2, square root plus a minus, so x is positive and negative 3. So that's where I need to start and stop. If I put a negative 3 in, 3 squared is 9, 6 minus 9 is negative 3. If I put in a positive 3, I also get out negative 3. If I wanted one more point, if I put in a 0, that one will give me 6. So there's my first little curve. If you weren't sure, if you put in another point on that one, you would get negative 12. So your curve, or your graph doesn't have to be perfect, just showing the general shape and those intersections. So, where am I going to start and stop? Negative 3 to 3. Are you girls okay?
I can just pass next time.
Okay. I mean, that's it today.
Yeah.
Okay.
Well, I didn't get any of the study guide right. So I'll just go over it this hour and figure it out.
Okay, come back if you need help. So we have to do, we're just doing area, so it's just top minus bottom. So what's the top curve? X squared minus the bottom curve. If you mix those up, how would you know?
Negative.
You would get a negative, and so then you could fix it at the end. Alright, so if I distribute my negative, we get plus 12, so 18 minus 2x squared. Okay, antiderivative of 18 is 18x minus 2/3 x cubed. So We plug in 18 times 3 is 54. 2/3 times 3 cubed. So 3 cubed is 27, divided by 3 is 9, times 2 is 18. Okay, if you put in -3, we get -54 plus 18. So, -36 minus -36 is positive 72.
Wait, did you only square when trying to find volume? Because it's only half. Okay. I was gonna question.
Yeah, area you just do, just
Okay.
subtract regular numbers. So number 12, we want area again. We need to find out where these meet, so if you set them equal to one another, subtract the 1, so you get y cubed equals y. Subtract over your y, can factor out a y. So you get y equals 0, 1, and -1. Okay, figure out our graph. If I plug in a -1 for my y, -1 plus 1 is 0, so x is 0. If I plug in a 0 for my y, 0 plus 1 is 1. If I plug in a 1 for my y, 1 plus 1 is 2. So here is my x equals y plus 1, just a 1. Okay, with these, you're going to get the same 3 points here. Again, the graph doesn't have to be perfect, but we need to figure out which one's on top. So if I put in maybe a -1/2 for my y, -1/2 cubed is -1/8 plus 1 gives us 7/8. So when my y is -1/2, I get 7/8. If I put in a positive 1/2, I get 1/8 plus 1, so 1 1/8. So when my y is a positive 1/2, we get just barely over 1. So we can kind of see there which one's on top. Again, if you get it wrong and you have them flipped, all you have to do at the end is make it a positive. So we're going to integrate. Do we want to do it with x's or y's here? Probably y's. That would be the easiest. So you need to make sure your limits are your y values. So starting when y is -1, ending when y is 0, plus the integral from when y is 0 to when y is 1. Okay, when you're doing with y, you do right minus left. So here my right is the y cubed plus 1, minus the left is y plus 1. Okay, this one, the right is the line, y plus 1, minus the left, which is my y cubed plus 1. My suggestion, before you try to integrate, simplify things. What happens when I distribute this negative? What happens to those 1s? They cancel, so we just have y cubed minus y. And this way it would be y minus y cubed. So, antiderivative of y to the third would be 1/4 y to the fourth, minus antiderivative of y would be 1/2 y squared, from -1 to 0. 1/2 y squared minus 1/4 y to the fourth. Are you guys all following and asking questions? If I'm losing you, I don't want you to just sit back and not say anything. Tell me if I lose you. If I plug in a 0, we get 0. Plug in -1, you get 1/4 minus 1/2. Plug in a 1, 1/2 minus 1/4 minus 0. So -1/4 plus 1/2 plus 1/2 minus 1/4. So we get 1/4 plus 1/4 or 1/2. Number 13. I want the area of the region bounded by the graphs. Y equals 3x plus 1, y equals 7, and the y-axis. All right, so the y-axis is this vertical line. Y equals 7 is a horizontal line at 7. Y equals 3x plus 1. So if we just plug in some numbers, we can't do negatives because we're bounded by the y-axis. So if we put in a 0, we get 1. Put in a 1, we get 4. Put in 2, you get 7. So I'm talking about this area right here. Do we want to integrate with x or y? Look, you could do either, except if I'm looking, if you don't want to have to solve this, if I want to keep my variable as x, we could just do it in terms of x. So my x, this starts when x is 0, it ends when x is what? 2. If you'd done it with y, you would go from, let's see, 1 was our lowest y value, 7 was the highest, so you'd go from 1 to 7, and then you would have to solve this for y. So then we do top minus bottom, so the top curve is just my 7, the bottom is the 3x plus 1, dx. So 7 minus 3x minus 1, so 6 minus 3x. 6x minus 3 halves x squared. Plug in 2. So 4 times 3 halves. 6. Plug in 0 and you get 0, so our final answer is 6. Hey, easy way to check this. What shape is that? What's the area of a triangle?
Length
1/2 base times height, which is like length times width, basically half a rectangle. The length of the base is 2. The height of this is 6. 1/2 times 2 times 6 is 6. We did it right. All right, then we got into volumes. Okay, so sketch the solid obtained by rotating the region bounded by x equals 3 radical y, x equals 0, y equals 9 about the y-axis. All right, so we're starting when x is 0. If you plug in a 0 for this, you get out 0. We're ending when y is 9. So if you plug in a 9 for your y, you get 3 times 3, which is 9. You could do more if you wanted. If you plug in a 1 for your y, you get out 3. So we see it's like this. I'm rotating it around the y-axis, so reflect it over. So we are getting just a bolt here. It's not hollow in the middle, so this is just your pi r squared. What variable do we want to do this in terms of? Probably y. This starts when y is 0 and ends when y is 9. We can see we have a definite bottom and top to our bolt. So pi, since those are y's, my tablet just died. It's not even Friday. My radius is just my graph, which is my 3 radical y. And then y, we put a dy on the end. Okay, so 3 squared is 9, square root of y squared is y. So the 9 pi can just pull out, antiderivative of y, 1/2 y squared, from 0 to 9. 9 squared is 81 minus 0, so we get 729 pi over 2. That one okay?
Dude, I couldn't do my hands. I got it set up right and stuff.
Well, that's the important part.
Just not I got it.
Alright, the next few I may not show all the integration work because I'm worried I'm going to run out of time here. I just want to make sure we have them set up correctly. I guess we've got about 10 minutes, so I might get through them. Okay, so number 15. We are going to rotate the curve y equals 8 minus 2x, x equals 1, and x equals 3 about the x-axis and find the volume. So when x is 1, that's our starting point. Plug in a 1, we get out 6. If you plug in a 3, we get 8 minus 6, which is 2. So we just have that little piece of it, reflecting it over the x-axis and rotating. So it looks like that. So we have a definite left and right. So we're going to integrate with respect to those x's. So from 1 to 3 of pi times my radius, which is just the function. Make life easy. Simplify before you integrate. So when I say that parentheses squared, you have to write it twice in FOIL. And then you would integrate from here. I will come back to it if I have time and work that part out. You should get 104 pi over 3. Is this okay? All right. Number 16, we have the curves y equals x squared and y equals the square root of x. And we're rotating around the x-axis. So it might be useful, since I didn't give you like a starting and stopping point for x, we need to find out where those meet. So I need to know when x squared equals the square root of x. Different ways of finding that. The easiest might be just to square each side. Subtract over your x. Here's common factor. So we get x to be 0 and 1. So those are the 2 points when these meet. That will also be my starting and stopping point when I integrate. So if we put in a 0, 0 squared is 0. If I put in a 1, 1 squared is 1. If you did something in the middle, 1/2. 1/2 squared is 1/4. So there's your x squared. If you put in square root of x, square root of 0 is 0. Square root of 1 is 1. If you did a 1/4, square root of 1/4 is 1/2. We are taking that and rotating it around the x-axis, so this little solid. So we get something like this. So it's hollow in the middle, so this is when we have to subtract them. So we're going to go from 0 to 1. I'm just going to pull out my pi. So you do the outside radius squared, So the outside is the radical x squared minus the inside squared dx. So we get x minus x to the fourth. And from there, you would integrate, you should get 3 pi over 10 for the final answer. Is this okay with everyone? The last problem is average value. So if you remember, average value is just integrating, but what do you have to put in front? The fraction, 1 over the length of that interval. So we are integrating from 0 to 5, so you can put 1 over 5 minus 0, interval from 0 to 5, of our function, 3x cubed minus 2x dx. So antiderivative of 3x cubed, antiderivative of 2x, and then you evaluate from there, and you should get 355 over 4. We have like 3 to 4 minutes. What questions do you guys have for me?
We have some multi-cosine stuff.
Probably not, because it's really hard to evaluate those with pretty numbers. Other questions?
Can we do another one like 2?
Okay. So if I said find the derivative of the integral from 3x to 4 of, let's say, so if I said to find the derivative of this integral, you have to know what the fundamental theorem of calculus tells you, which is that you can plug in that 3x, right? But fundamental theorem needs to go from a constant up to the variable. So what would I have to put in front? A negative. Then I replace all of my u's with the 3x. And what else do we need to do? Times the derivative of 3x is 3. So 3 squared is 9, times 2 times 3. So if I ask you to do the derivative of the integral, you're just plugging that variable in.
So we don't do plus c on those.
No. If you integrated, you would have a plus c, but then when you did the derivative of a constant is 0, so it would go away.